In this video, we will be going over the electric charges section of the AP Physics 1 electricity unit. A few things that we're going to go over that you may already remember from chemistry is that all matter is made of atoms which are in turn made of protons, neutrons, and electrons. Some things to remember about protons: they're positive, and they are located in the nucleus. And we're going to abbreviate them as a P with a plus sign. For neutrons, they're neutral, which means they have no net positive or net negative. They're also located in the nucleus. And we don't really care about them for this topic. Finally, we have our electrons. They're negative. They're located around the nucleus. We're going to abbreviate them as an E with a negative sign. An object, and this is a macroscopic object, is positive when the number of protons is greater than the number of electrons. And we have, and a macroscopic object is negative when the number of protons is less than the number of electrons. That is just our base definition for when an object is positive or an object is negative. As far as how positive or how negative they are, that is all based on the elementary charge, which we're abbreviating with a little e. And I know it can be confusing because we have E for electron. This is just a lowercase e with no negative sign, stands for the elementary charge. This is the charge on a positive or on a proton or an electron. So I'm going to give it a little plus or minus. 1.6 times 10 to the negative 19 coulombs. That's the charge on a single proton or electron. AKA the elementary charge. So that is the charge on one proton or one electron. If it's a proton, we think of it as positive. If it's an electron, we think of it as negative. A lot of times when we're doing calculations with this, we don't really worry about it being positive or negative until we think about it at the end. A lot of times with electricity, positives and negatives, we just need to think about them a little bit more. So I would rather you stop and think, should it be positive, should it be negative, than just remember that it's always positive or it's always negative or there's a plus or minus. This is the base unit of charge, which means that we cannot have an increment of charge that is not an even multiple of this. So all charges are made up of integer multiples of the elementary charge. We could have 1.6 times 10 to the negative 19, or we could have 3.2 times 10 to the negative 19, or we could have 4.8 times 10 to the negative 19. Any integer multiple of that number. We cannot have half a proton. We We can't have 0.8 times 10 to the negative 19. Or we can't have 2.4 times 10 to the negative 19 because that's not an even integer multiple of the elementary charge. So, just a quick math example of how to do this. How many extra electrons are present if an object has a charge of negative 5.0 coulombs? So I'm going to start with the value I know, negative 5.0 coulombs. And I would like to cancel out coulombs because I don't really care about coulombs. I'm asking how many electrons. So I want the number of electrons. For this, I need to know how many coulombs there are in an electron. One electron is negative 1.6 times 10 to the negative 19 coulombs. I throw that in my calculator. I get 3.125 times 10 to the positive 19 electrons. There is a note that we have to add. While we think of a positively charged object as having extra positives, in reality, it has lost negatives. This is because the protons that are in the nucleus are unable to move. Only the electrons can move. A lot of the work that was done with electric charges and electric force and basic electricity was done long before we knew that there were protons and electrons in the atom, before we knew what was going on with the atom. This was done back in the 1700s. The atom was not really discovered as we know it until the late 1800s, early 1900s. So a lot of the work that we're doing, we're just going to say we have a positively charged object. And according to the descriptions at the time, that meant that it just had extra positives. But in reality, we know that it doesn't have extra positives. It can't have extra positives. It had lost negative charges. So that's just the basic introduction to electric charges. Again, this was mostly a chemistry review. We're going to get into physics in the next video.